Hey, welcome all. So today we are going to solve fifth problem, majority element. In the last video, we saw remove duplicates from sorted array part 2, and today we are going to solve this fifth problem. Okay, so we have given an array nums of size and we have to return the majority element. Majority element is the element that appears more than n by 2 times. And you may assume that the majority element always exists in the array. So let's try to understand with this example 3, 2, 3. So we have given this nums array 3, 2, 3. So size of this array would be 3. And if I take n by 2 of this, it will come as 1.5. And we can say an integer, it's a 1, right? Now I'll take a frequency of 3. 3 appears 2 times. And this 2 appears 1 time. Is 1 greater than this one? No. N by 2 times? No. And this 2 is greater than 1? Yes. So this 3 we have to return. So answer would be 3, right? 3 is the majority element here. We can see here also. So what we did simply, one solution we can say that we can create a hash map and we can keep in the hash map, we can keep a frequency of each number and our hash map will look like this way, right? And then again, if I run a loop on that hash map and compare each frequency with this n by 2 value, and wherever I see if this frequency is greater than this, 2 is greater than this frequency 1, that time I'll return the key element and that would be my answer. That is the one way of solving this problem. I'm not going to write a program for that one. I'll tell you why. And then another solution is going to be very easy also. It's going to be two-liner solution. Do we can sort a array, and once we sort a array, it is guaranteed that majority element always exists in the array. That is what they have said in the question. So when you sort the array and if you return the mid element, that is going to be our answer. And that is just a two-liner, right? Let me quickly write it. And if I return mid element, nums I 0 plus nums dot length, and if I say here one bracket divide by 2, this will solve our problem also. But the problem is that, yeah, this is accepted. And if I submit, this should accept it. This is just a two-liner solution, right? But if you read the question further, the main part of the question is that could you solve the problem in a linear time? This is not in linear time because when you say arrays dot sort, complexity would be n log n, right? So this is not linear, definitely. And also they're saying that you need to solve this problem in big O of one space. If I write a hash map solution, that's the reason I said I'm not going to write a hash map solution, because if you write a hash map, it will take extra space, right? So we have to solve this problem considering these two conditions, right? So what we can do here, we can use very famous Boyers-Murray voting algorithm, and with that algorithm, we will try to solve this problem. Okay, so we will use that voting algorithm and we will solve this problem. So let's take this example 2 2 1 1 1 2 2. So here what we are going to do, we will use Boyers-Murray voting algorithm. Okay, this is the algorithm name which we are going to use. So what input we have got it here, let's say 2 comma 2 comma 1 comma 1 comma 1 comma 2 comma 2, right? This is the input which we have got. Now initially we will assume that this 2 is the potential candidate, or which is going to be major element, or going to be our winner candidate, I can say. So integer cand equal to 2, like first number, I'm saying first number will, I'll always assume that this is going to be my winner candidate. Now I'm assuming this is my winner candidate, and I'll keep a counter also, like this person got one vote so far. one vote because it's a voting algorithm. So I'll talk in those terms only. So this person got one vote. Okay. This second candidate, name of the candidate is 2 and he got one vote. Okay. Now I'll start a loop. I'll run a loop here from this place. Okay. Now I'll compare this candidate with this winner's candidate always. If this is matching, it means this candidate got another vote, right? It means I'll increase my counter. So if, like in my first iteration, what will happen? This 2 is matching with this winner candidate. Yes, it's matching. So counter will become what? Counter will get increased. Counter is 2 now, right? Now counter will become 2. Now iteration loop will come here. This 1 will get compared with this winner candidate. This is not matching. It means this person will lose one vote, right? If this person got 1 plus 1 vote, it means this person will lose one vote, right? Definitely from the total votes. So I'll minus from this counter. So in the second iteration, my counter will become 1. So when, if it is matching, I'll do the plus plus. And if it is not matching, I'll do the minus minus, right? Now third iteration, still the winner is candidate is 2 only, right? Now, now 1, I'll decrease my counter. Now, if I see our array is look like this way, right? So far, I have compared these values. So if you see, this is not in majority now, neither this is in majority now, right? Now counter is 0. Now if counter is 0, it means I have to write a condition. If this counter is 0, this is not winner anymore. Now this candidate I'll assume is my winner. So I'll write one condition. If counter is 0, if counter is 0, then this candidate will become a new potential candidate, and I'll set my counter equal to 1 for this one now, right? I'll set my counter to 1. Okay. Now in third iteration, I got my new candidate, and what is the candidate is 1, and for this counter equal to 1 at the end, right? Now in fourth iteration, let's see what happened in fourth iteration. Now this one will get compared with the potential candidate. Yeah, it's matching. I'll increase my counter. My counter will become 2. My counter will become 2. This 2 will get compared with the potential winner candidate. And our potential winner candidate is 1 right now. This is not matching. It means at the fifth iteration, counter will get decreased to 1. That's all, right? And still the candidate is 1 only. Now this iteration, last iteration, 2. 2 will get compared with this candidate, not matching. My counter will become 0. I mean, the last iteration, my counter will become 0. And I have said when the counter becomes 0, we are saying that we are one is not anymore a potential candidate. Who is going to be now candidate? This num, this 2, right? And I'll increase the counter. That's here. And we got our candidate. I'll return my candidate. So if you see who is the winner, 2. And if we see clearly also, 2 is the winner here. So let me try to write a code, then you will definitely able to understand. Int candidate, I can say. I said first element I'll always assume is going to win, right? Then I said he got one vote initially, right? Whoever it is. Then I said I'll run the loop, start from first position. That's what I said, right? Then what I said after that, we will compare this potential candidate with num's candidate. If it is matching, means he got another vote, right? So I'll increase my counter. But if it is not matching, it means indirectly he's losing one vote, right? Right? And I said if counter becomes 0, that time this is not a winning candidate anymore. So my new candidate would be whatever the nums uh, position right now, and I'll increase my counter because this is my new candidate, and whatever value in the last at the last iteration at last position that I'll return. Here, no, this is loop is ending here. Here I'll return, and this is going to be my answer. Okay, let me try to run this. Okay, this is accepted. This is accepted. So this is the voting algorithm which we used, and here we solve this problem in a linear time and also with big O of one space complexity. Thank you. Thanks all.